Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is antiderivatives. At this point, we have seen how to calculate derivatives of many functions, and we have introduced to a variety of their applications too. We now ask a question that turns this process around. Given a function f, how do we find a function with the derivative f? And why would we be interested in such a function? We answer the first part of this question by defining antiderivatives. The antiderivative of a function f is a function with the derivative f. Why are we interested in antiderivatives? The need for antiderivatives arises in many situations, and we look at various examples throughout the remainder of the video. Here we examine one specific example that involves rectilinear motion. In our examination in derivatives of rectilinear motion, we showed that given a position function s of t. Hope you have watched that video. For now, let's look at the terminology and the notation for antiderivatives and determine the antiderivatives for several types of function. We examine various techniques for finding antiderivatives of more complicated functions. Now let's start with the reverse of differentiation. At this point, we know how to find derivatives of various functions. We now ask the opposite question. Given a function f, and how can we find a function with the derivative f? If we can find a function capital F derivative f, we call f an antiderivative of this f. This is a capital F and this one is small one. A function f is an antiderivative of a function if f dash of x is equal to f of x for all x in the domain of f. You have to know the difference between these two functions. Consider a function f of x which is equal to 2x. With this example, we can understand the basic. Knowing the power rule of differentiation, we conclude that f of x is nothing but x square, which is nothing but an antiderivative of f, since f dash of x is equal to 2x. Are there any other antiderivatives of s? Yes, since the derivative of any constant c is 0, x square plus c is also an antiderivative of 2x. Do you all agree with me? Therefore, x square plus 5 and x square minus square root of 2 are also antiderivatives. Are there any other that are not of the form x square plus c for some constant c? The answer is no. Okay, let me explain you the general form of antiderivative. Now let us see the general form of an antiderivative. Let f be an antiderivative of the function f over an interval I. Then there are two statements. First one is, for each constant c, the function f of x plus c is also an antiderivative of the function f over the interval I. The second point is, if g is an antiderivative of the function f over the interval, same interval I, there is a constant c, for which the function g of x is defined as f of x plus c over the interval I. You can also say this in other words. The most general form of the antiderivative of the function, I mean the small f, over the interval I is f of x plus c. Hope you are clear with this general form. Now we can use this fact and our knowledge of derivatives to find all the antiderivatives for several functions. Let me take few examples. Here is an example. For each of the following function, find all antiderivatives. Let us start with part A. f of x is equal to 3x square. We can find the antiderivative because d over dx of x cube is equal to 3x square. Am I right? Let me write it on the board. So if this is true, we can say that f of x is equal to x cube, which is an antiderivative of 3x square. Hope you're clear with this step. Therefore, every antiderivative of 3x square is of the form x cube plus c for some constant c, and every function of the form x cube plus c is an antiderivative of 3x square. You can say from this to this or from this to this. Hope you're clear with part A. Okay, now let's do part B. Here is your part B question. We are supposed to find the antiderivative of this function. let f of x be ln of x for x greater than 0. D over dx of ln is equal to 1 over x. Am I right? Hope you're clear so far. Same way, for x less than 0, f of x would be ln of negative x. Same way, you can define that d over dx of ln of negative x would be negative 1 over negative of x, which is nothing but 1 over x, the same thing. Therefore, you can say that d over dx of absolute value of ln of x, because for both the cases you get the same answer. So you can also define that d over dx of ln of modulus x would be equal to 1 over x. Thus, you can say that f of x, which is equal to ln of absolute value x or mod x. This is an antiderivative of the function f of x is equal to 1 over x. Therefore, every antiderivative of 1 over x is of the form ln of x plus c. C is just a constant, and every function of the form ln of x plus c is an antiderivative of 1 over x. Hope you're clear with part B. Okay, now let us move on to part C. Here is a part C question. Now we have that d over dx of sin x is nothing but cos x. You have to find the reverse here. Only by defining so, it will be very easier for you to identify the antiderivative. So, the function capital F of x is nothing but sin x. This is an antiderivative of cos x. Therefore, every antiderivative of cos x is of the form sin x plus c, where c is some constant, and every function of the form sin x plus c is an antiderivative of cos x. Does this make sense to you? Okay, now let's move on to part 4, part D. Here is a question, f of x is equal to e raised to x. Now it is easy for you to define because derivative and antiderivative of e of x is nothing but e of x itself. D over dx of e of x is nothing but e of x. Am I right? Then e of x is an antiderivative of e of x. Therefore, every antiderivative of e of x is of the form e raised to x plus c for some constant c. And every function of e of x, e raised to x plus c is an antiderivative of e raised to x. Hope you are clear with this example. All the 4 types of function. Okay. Now let us discuss about indefinite integrals. We now look at the formal notation used to represent antiderivatives and examine some of their properties. These properties allows us to find the antiderivatives of more complicated functions. Given a function f, consider this function, we use the notation f dash of x or df over dx to denote the derivative of x. Derivative of f. Here we introduce notation for antiderivatives. If capital F is an antiderivative of small f, we say that f of x plus c is the most general antiderivative of the function f, and we write this in this format. This symbol is called the integral sign, and integral f of x d of x is called indefinite integral of f. Hope you're clear so far. Now let's see the definition for indefinite integral. Given a function f, the indefinite integral of f denoted by integration f of x d of x is the most general antiderivative of f. If f is an antiderivative of the function small f, then integration of f of x dx is equal to f of x plus c. This expression f of x is called the integrand, and the variable x is the variable of integration. So this is called the definition of indefinite integral. Hope you're clear so far. Given the terminology introduced in this definition, the act of finding the antiderivatives of the function f is usually referred to as integrating f. For the function f and the antiderivative, the right side one, the functions f of x plus c, where c is any real number, is often referred to as family of antiderivatives of f. For example, I'm going to take a very simple example, the one that we used in the starting of this video. Please notice that for this example, x square is an antiderivative of 2x, and any antiderivative of 2x is of the form x square plus c. So we write that integration of 2x dx is equal to x square plus c. You can try to draw a figure or a graph for x square for some numbers like 2, 1, 0, -1. You can just change the numbers and draw a graph on the same grid. The collection of all the functions of the form x square plus c for any number, for any real number c, is known as the family of antiderivatives of 2x. Hope you're clear with the concept so far. In case if you get any query regarding this video, you can let me know. See you in the next video. Have a great time ahead. Thanks for watching.